Aha! I see you are doing chemistry, and so I did not bring my water this time.
Excellent.
Thank you. I was very proud of myself. Had a drink over there.
Good job.
All right, so what are we doing?
Well,
You have a lot of water.
I have a lot of water. So we have our blue colored water, so that we know that it's blue colored water.
Blue coloring, yeah.
So I thought what I would show you, as we've been talking about polymers and how there are some that we can cross-link, and there are others.
Chains and yep.
Yeah, so we've been talking about the properties of a lot of these polymers.
Yes.
And properties are a way for us to describe things, and we categorize things based on properties, like tall
and
not tall,
not tall,
average, above average.
Well, yes.
There you go. So what we'll do is I'm going to show you the properties of some polymers. So my first polymer right here, what does it actually say on there?
It says instant snow polymer.
That's right. So this is a polymer. So we're going to take a little bit of this, not much.
All right.
We're going to put it in the cup.
Okay, that is definitely a tiny bit.
So it's a plain white-looking white powder. And then we're going to add, actually, I'm going to let you do it. Add just a little bit of water.
Just a little bit of water.
Yeah.
Okay. Whoa! I'm going to add more. I bet if I add more, it's going to get even bigger.
Okay, try.
Oh, that is so cool.
See how it's expanding?
I do see how it's expanding.
The property of this particular chemical, this polymer, is that it is hydrophilic.
Hydrophilic. What does that mean?
Hydro means water.
Well, yeah.
Philic means loving. So water.
Oh,
loving.
it loves water. That's very cool. And yeah, wow, that definitely expands. Oh, that's cold.
It is, yes.
Is that why they call it snow?
That's why they call it instant snow. Yes.
That is very cool. Wow, look at how much I got out of that tiny little bit.
Well, and if you look on the back, you can tell there's a lot that you haven't even, stirring it around, you're going to be able to reach more of the chemical.
It's getting bigger and bigger.
We put
because more water is getting absorbed.
this amount in there.
Yeah, that's crazy. Look at that. Like, wow.
Quite a lot of volume.
That is quite a lot of volume being generated. And it's wet too. I mean, I guess that makes sense. It absorbed the water, and so I can feel a little bit of water with it.
Right, so what happens with this is that the water goes in between all of those cross links of polymers. And that's what happens.
And that's how it expands. That is super cool.
Yeah. So what we'll do here is we're going to do this two different ways. Something that you might not have at home, but something you probably do have at home.
Okay.
So this is called magic sand.
Oh, I know what that is.
This is sand that has been coated with a hydrophobic polymer.
So it repels or is afraid of water. Okay.
So we can put some on top of this.
And it will totally not absorb into the water.
It doesn't absorb. It will drop into the water. I'm trying to be gentle so that I don't have too much force. But then I can take my finger, put it in here.
Oh,
and my finger comes out dry.
Super cool.
If I put enough on there.
Wow.
Ah, yeah, you ended up pushing it down to the bottom. No, it's okay. That happens. You have to put just like a little skin on top.
So, I'm probably getting out of, but is this surface tension that's holding it up?
Well, the water has surface tension. And yes, this is sitting on top of the water. So we have two things going on. Water likes to stay together.
Right.
And this hydrophobic sand
likes to stay together.
Wants to stay away from the water, so it's staying on top. So we have the surface tension supporting it, and all this down here was not supported. And here's the cool thing: we pour off the water.
The sand stays.
And the sand.
Oh, and it's dry again. That is super. That's really hydrophobic.
Yeah.
Oh, and look, you can see the little like water droplets sticking together because of cohesion, but they're totally being repelled by the sand.
That's exactly right. Now, something that you can do at home.
Okay.
If you have cinnamon at home.
Okay. Most people do.
Most people have cinnamon at home, so I'm going to make sure my water. You can take cinnamon. Cinnamon is hydrophobic as well.
Oh, I did not know that.
Yeah.
Okay.
I recently just learned it, so. So so this is not just cinnamon, this is a pumpkin pie
spice. I see that.
So it's going to have a lot of different,
it smells delicious.
it's got allspice and nutmeg, and I don't know the properties of allspice and nutmeg, but I'm going to sprinkle some of this on top of the water. Now I'm going to be able to push my finger.
Because it does the exact same thing.
Exact same thing, and that cinnamon is now all dry on my finger.
Whoa, it's totally dry.
It's totally dry on our fingers, yeah.
That's so cool. So, surface tension, holding the thing up, and then hydrophobic material staying on that.
So this is just showing you a property of different materials out there. Hydrophobic, hydrophilic.
Super cool.
And these two are polymers. I don't know enough about cinnamon to tell you about that, but I'm definitely going to go research that.
Well, yeah, and I'm really curious about what happens when it goes into your body now. That's kind of cool.
I guess we're going to have to do some research.
Because we're 80% water.
We are. Let's go check it out.
All right.
Okay, cool.